This is the P5 Block 1 webinar to support the implementation of the new Glasgow City Council Numeracy and Mathematics Progression Framework. If you haven't done so already, you can join the Microsoft team where you'll find all associated documentation and also recordings of these webinars. So there's much that is familiar about these new progression planners, but there are some things that are different. And I'll just run through the main messages here. So we will still have an annual overview on a one-page document where you can see the content that's to be covered by each primary stage. Research hasn't changed, so we're still looking for you to use the CPA approach, offering concrete examples of a new concept before moving on to pictorial and then abstract notation. And that goes for introducing new concepts like decimals or percentages at the school. Problem solving should still be very much at the heart of your teaching, offering lots of real life context and providing purpose for our learning. We'll have high expectations of fluency with mental strategies as ever, so number talks and providing lots of practice and retrieval of mental arithmetic strategies will be central to the learning. These progression planners are still based on the Curriculum for Excellence. We know we're in the middle of the curriculum improvement cycle, and over the course of the next session, we will be getting new curriculum documents published. The senior education officers involved in these new progression planners have been involved in the curriculum improvement cycle working parties, and so we are confident that there will need to be only minor improvements and changes to align with Education Scotland's documents as they come out. What it means though is that all the resources that you have in school that you've used to support the delivery of maths in the past will still be relevant and useful in delivering the teaching points on these planners too. So really the thing that's new about the new planners is that instead of having the annual overview as a single piece that you then are splitting up and deciding when to teach what yourselves, there is a 6-block planning structure. The suggestion is that each block will take around 6 weeks to deliver, and you'll see that each block offers a sort of bite-sized chunk of the progression of various number concepts. We'll be revisiting those core number concepts in every single block so that addition and subtraction will be seen every 6 weeks, and we're just extending those skills and building a little bit on what we did last time. There will be end of block assessments available for you to use if you wish. Those are in development just now and will be communicated very soon in the new year. Alongside the annual overview, you also have a suite of medium-term planners, so a A3 planning document for each block, and that comes with some suggested learning intentions just to help you to think about how you might cover the content over the course of 6 weeks. What is a little bit different from our previous Glasgow Counts trackers is that we have a more directed approach to which strategies for calculation are age and stage appropriate. And here we're talking about for on-track learners. And that's because by the end of primary 7, we do want our pupils to be moving on to the most efficient calculation methods, to be moving on to those formal algorithms, because what we want to avoid is very able mathematicians moving up to secondary school, but still using the grid method for long multiplication. If they are able to use a more efficient column-based method, this will save them time, and whilst that isn't an issue or a priority further down the primary school, as they get to secondary, and they've got to get ready for taking timed examinations like the National Fives and beyond, we need to make sure that we are freeing up that working memory and allowing them to move on as quickly as they can in complex problems. So your annual overview looks something like this. Hopefully you have access to the PDFs of these documents, but just in terms of navigating them, the title sits up at the top in the middle there. They are labelled by primary stage because we're trying to underline where an on-track learner should be. Always mindful of the fact that not all children will be working at this level at that stage. So as with the previous trackers, you may well be working across 2 of these annual overviews or more, depending on the profile of children in your class. Up at the top, the headings there are indicating each block of teaching, and there's a suggestion of the months of the calendar year that you would be delivering these in order to move through the blocks at a suitable pace such that you've covered them all by the end. They do align with the ACEL tracking, tracking and monitoring deadlines, so the pink vertical columns after blocks 2, 4 and 6 are where your monitoring and tracking cycles come, and between each of the other blocks you've got a separator just saying that there's a end of block assessment available should you want it. Down the left hand side, as we used to have with the Glasgow Counts trackers, you've got the organisers to show which parts of maths the teaching points relating to. The core number topics have teaching points across all blocks, but then further down the tracker you'll find that the beyond number topics are grouped and you've got a couple of areas in each block to cover. More about that later. The blocks then run vertically, so the part in blue is block 2, for example. So during block 2 you would be working through the teaching points in that section. And alongside those overviews you've got a page per block as well. So this overview has the teaching points, the core teaching points for this block copied across from the annual overview in the central column. And then to the left and right of that column, you've got teaching points around support and challenge. So what you have there is a sort of mini progression of teaching points across support, core and challenge, just to help you navigate how you could differentiate your learning for the children in front of you. It's worth saying that the support and challenge points are just the steps before and the steps after in the progression. As mentioned before, you might well have pupils working several steps behind, and so in that case you would need to look at a different planner. Also on that page to the right hand side you have a list of suggested learning intentions. These are to help you see the sort of pace of moving on that is required to cover that content over 6 weeks. Really the main departure with these new planners is that we're expecting not to teach addition and subtraction for a whole week or 2 weeks, but perhaps only for a few lessons within 1 week, because we're only going to teach 1 or 2 skills and then come back to it and add on to those skills and so on. So this is called a spiral approach, and it enables pupils to have time to digest and practice some of the concepts before revisiting them. The learning intentions are also provided just to support early career teachers in terms of what a learning intention should sound like, how simple it can be. We're trying to demonstrate that the specifics of the learning should not be in your learning intention. They should sit in your success criteria and therefore can be differentiated, because it's much better for you as teachers and for the pupils if everybody in the class is working from one learning intention. And so you'll find that they are very generalized in terms of we are learning to add, we are learning to count. And within that, there may be pupils working on that concept, but at very different levels. And that's really our aim, is to have everybody working on the same concepts together, but perhaps achieving them at different stages. That's more child friendly and reflects best practice. The other thing to say is that to reflect how teachers tell us they currently plan, each week of those learning intentions offers learning intentions with core number topics as well as some with the beyond number topics. We know that many job share partnerships divide the labour in that way, and so although the block runs top to bottom down the page, we are aware that some of the beyond number topics will be getting taught throughout. So for the remaining time, I'm going to run through the block, and for the sake of clarity, taking each organiser in turn, but as we've just mentioned, and as you will very much know and do in your practice, we know that core number skills, like the ones particularly in this first organiser, will come into other lessons as well. So number system and number fact recall is our first organiser. All of these points are around extending that confidence with our number system up to numbers to 10,000. So by the end of P4, we have got the children familiar with numbers up to 1,000. We're now introducing that extra column of whole number, and we're going to lay on to the knowledge they already have of numbers to 1,000, how this can work for higher order numbers. And of course, skills like partitioning will be needed when we look at calculation as well. So as I said, very much building on strategies and visualizations they will be familiar with from 3-digit numbers. Lots of place value counters are required from this point on, because our Dean's materials become a less useful resource beyond the hundreds. So making sure you've got place value counters available in your classroom, or using the very helpful digital versions of those manipulatives. So you may be familiar with MathSpot, and the place value chart screenshot on the top left there is from a White Rose Maths resource that's available for free online too. Pupils, if they have access to and are confident with their iPads, can use these digital interfaces to provide effectively a concrete model of partitioning. They can be screenshotted, marked up and shared, airdropped to you or mirrored to the screen. And we do tend to focus a lot on the partitioning by the columns, by partitioning in that regular way. So that's because the base 10 system of our number system is the thing that we're trying to get really embedded. However, from primary 4 onwards, we also want them to become familiar with partitioning in different ways. So as in the handwritten example there at the bottom left, having them familiar with splitting up a large number in lots of different increments, and that will help them to attempt mental calculations in different ways. Because if we are wanting to do halving, it might be better to split up a number into familiar multiples of 2, for example. So lots of online things, but ultimately we are getting our pupils familiar with higher order numbers at this point. So again, building on skills they've developed through primary 4, we're extending their skills around estimating where the position of numbers falls on a number line by extending the numbers up beyond 1,000. So the process is exactly the same. If they have had exposure to these strategies in P4, then again, it will be a familiar process. We're just upping the values. And the steps are the same, whatever order of numbers we're talking about. Whenever they've got an unmarked or partially marked number line, they're needing to look at the range of that number line. So we've got two examples here, both starting with 1,000 and ending in 10,000. They need to have a look at any midpoints and increments that they've got that are unmarked and work out what those increments are indicating. And then, if necessary, as in the second example with the little pink arrow marker, they may have to look at subdividing those increments to be able to give a good estimate of what's being pointed to there. Yeah. If you want to practice it the other way around and be able to mark a number on the number line, then there's a really good digital game or digital manipulative, if you like, that's linked to there at the bottom left. It's a version where you can make lots of choices about what the range of your number line is and what the increments are, how many increments there are. So it's very much differentiable, and it's also usable on the iPads as well. But ultimately, what we're trying to do here is to build their confidence and skills so that if they were presented with a completely open number line, as in the bottom right example, they've got those skills of, well, what do I know? Where am I starting? Where am I finishing? Where's the middle of this? And what would that represent? What else can I do? Can I subdivide again? And so on. And this will set them in good stead for working with fractions as well later on. And very much related to that number line work is our skills around rounding. So when we are rounding, we need a mental number line to visualize where the target number is in relation to increments of 10 or 100 or 1,000, depending on what we're rounding to. So it's really important that pupils see rounding modelled on a number line. There's lots of rhymes out there for helping them to remember, and we talk about looking at this column or that column and what the digit is in this column or that column. That's fine, but actually lots of counting routines and helping them identify the increment, the 100 before that number and the 100 after that number will make the conceptual understanding much stronger. So in that top example there, round 5,845 to the nearest 100. In order to do that, really our pupils need to be familiar with counting in hundreds up to those sorts of numbers. So how often do we actually practice counting in hundreds from 5,000? So we would start 5,000, 5,100, 5,200, 5,300, and so on. If we are familiar with that, then the pupils will be able to tell you that this number, this target number 5,845, is somewhere between 5,800 and 5,900. And they could also tell you that halfway between those two things is 5,850, and 5,845 is less than that, so it's nearer to 5,800. Okay, so those counting skills, that familiarity with the number system and being able to identify the 100 before and after, or the 1,000 before and after, is really, really important. And just on the third example down there, we also need to point out this unusual and quite counterintuitive idea that sometimes the nearest 100 or the nearest 1,000 might be 0, which doesn't feel like 100 or 1,000 at all. So whichever order of numbers we're working on, we're identifying the number before and after. What's the midpoint? Is your target number nearer to one end or the other? And we also need to understand that exception of if it's exactly in the middle, then we round up, okay, which is what a lot of the rhymes refer to. Moving on then, these are the last teaching points in number system and number fact recall. What we're trying to build through this progression is an expectation that certain number facts become embedded and become quick recall facts for our pupils. In terms of number bonds, we've worked on number bonds to 10 through primary 1, 2 and part of primary 3. Then they've extended that to number bonds to 20 and made those links between 9 and 1 and how that relates to 19 and 1, for example. We've then moved on during primary 4 to finding those friendly numbers by using our number bonds. So how do we get to 70 from 43, making one jump that takes us up to the next 10 and then the 10s beyond it. And now we're extending that to 100 and being able to mentally calculate number bonds to 100. And what that's providing for them is a foundation for things like finding change, which is sometimes a difficulty. And we know the common misconception of forgetting that the units are going to make the final 10. So in the first example, 69 add what? It would be a very common mistake for mentally children to tell you that it's going to be 41 and 69 would make 100 because they're trying to make both of those columns add up to 10. So what we want to get is a mental visual of an open number line where they're starting at the 69 and making a jump to the next 10 using their number bonds to 10, and then they're continuing up to 100. So in which case we've got a jump of 1, and then if they're confident, they might then know that from 70 it's a jump of 30 up to 100. And again, that's related to our number bonds to 10, so we can make those links for them. Or else they might need to count in 10s on to get to 100. But we're trying to build that facility, make it really automatic for them to understand how these things relate to their much earlier knowledge. And then in terms of times tables, we want to free up the pupils' working memory for when they're moving on to multi-step and more complex problems as they enter secondary school. So the progression planners introduce the 10 times table in primary 1, the 2s and the 5s in primary 2. We're then introducing the 3s and the 4s as we move into primary 4. And then as we move into the upper school, this first block here is a consolidation block. We're just going to revise those 5 core times tables. And then actually, because every time we've introduced a times table, we have underlined the commutative law, by this point, even though we haven't focused on the 6 times table, they already know 2 times 6, 3 times 6, 4 times 6, 5 times 6, and 10 times 6. So by building it up very slowly through the primary stages, we actually get to a point where we're consolidating and then actually just learning very few additional facts through the rest of primary 5, 6, and 7. And that means we've got a longer time to embed that. We do want their conceptual understanding to be really strong, so they should understand that a times table is a repeated addition pattern and that each station is adding another multiple of that number. And we also want them to be really confident with that, so that if they can't manage to quickly recall something, they've also got another strategy. So for example, they haven't learned the 9s yet, but they know their 10 times table, they should be confident enough to think, well, I know that 6 times 10 is 60, so 9 times 10 is 6 less than 60, so I'm going to count back 6 and I'll find that it's 54. So having that manipulative knowledge of the stations, understanding that they can start from a known fact and move forwards or backwards is still completely valid. We want them to recognize those patterns, want them to have that understanding. But equally, if they can move beyond that to having a quick recall, memorization for as many of the facts as possible, then it will save them time in their exams. So in order to do that, we can use chanting, we can use songs, we can use frequent recall practice, and I would advocate that we've got available to us now lots of digital platforms which offer what I would term individualized practice. So we still absolutely want to avoid that sort of public shaming type situation where children are pitted against each other to see who remembers, or where it's very obvious that a child doesn't know particular facts. But we can offer them individualized routine practice either through SumDog or Magma Maths or any number of online games and so on, like Hit the Button, so that they can practice the tables they individually need to work on. And that should be the aim, is that it's an individual pursuit rather than anybody being better than anybody else. Good, so moving on, our next organizer in the block is addition and subtraction. In this block, we are adding and subtracting up to 4 digits, including bridging, so including where we're having to make some exchanges and so on. And we're going to do it in 2 ways. We're going to be doing it with partitioning first, and then we're going to be doing it using the formal algorithm. So in terms of partitioning, in primary 4, we have modelled with concrete materials how partitioning can support with addition. By the time we're moving on to primary 5, we want to move a slightly more abstract, but if pupils aren't ready for that, absolutely, we can still use the manipulatives. In this example then, we're going to partition the 2 large numbers in order to add them. So we've got our thousands, 4,000 and 2,000, make 6,000. We've got 300 and 900, making 1,200, 20 and 10, and 4 and 8. And then they would be adding all of those together to find the final result. And when we do it in this way, the exchanging isn't really bothersome because we're just adding those 2 numbers and bridging as we go. So 6,000, add 1,200, add 30 and 12 will give us a result of 7,242. We could also be using number lines for this, and I would suggest you model it that way for subtraction, because if we were to do the same strategy as we've just seen for addition, with subtraction you'd end up with negative numbers and so on. So we're going to start at 4,324. We're going to then take away our thousands, take away our hundreds, and in this case we're splitting it up to help us find that friendly number of going back to 2,024. Then we'll take off the 600, that's a bit safer for us. And then we're taking off a 10, and then we're taking off 8. And we find that our answer is 1,406. Okay, so these are partitioning strategies. When we're moving on to the formal algorithm, I would suggest that you model it alongside a physical example or a visual example. So if we were to add 137 and 169, we would be looking at the units first. So we want to model that we do units first, and we're completing this 10 here to realize that we've now got 16 units, and 16 units appears in the formal algorithm in this way. So the 6 units remain but the 1 of the 16 is sitting in the tens column, and that's because with our physical example, we would be exchanging this for a tens counter, for a 10 counter, and pulling it across into the tens column. And that way they can very clearly see why we're putting this 1 in the tens column. Now we're doing the same with our tens. We can see if we combine these, we're going to end up with 10 tens. Again, in our formal algorithm, it needs to sit with the 1 of our 10 in the hundreds column, and that's because we would be making an exchange here. We would be carrying this over into the hundreds column. Okay, that's an example just with 3 digits, but the principle applies to 4-digit numbers, which is what we are looking for them to have a go at here. The subtraction version of that, just so that they can also understand how it relates. If we have 345 and we're wanting to take away or subtract 129, then in our formal algorithm, we start with our units and we are saying we have 5 and we need to take away 9, but it's not possible to do that when we've got our physical counters. In order to do that, we need to make an exchange. We need to take one of our tens counters and convert it into 10 ones. So we've now got 15 ones sitting there. And in the formal algorithm, that looks like this. We've got rid of one of the 4 tens, so we don't have 4 tens anymore, because one of the tens is over here making 15 ones for us, and it's left us with 3 tens. So they can very clearly see from the visual that that's what we've got. We've got 15 ones now, because we've borrowed one of those. We borrowed one of those tens and turned it into 10 ones to help us. And we've been left with 3 tens. So we now have numbers in our algorithm we can work with. We've got 15 ones, take away 9. We've got 3 tens and we're going to take away 2 of them. And that's leaving us with 1 10. And we had 3 hundreds, but we're taking away 1 of them, which is leaving us with 2. So they can now very clearly see that left in the original spot, they've got 2 hundreds, 1 10 and 6 ones, so 216. And so if we can provide that visual, it means that when they're moving on to the abstract formal algorithm like this, they've got that partitioning understanding. So when we're moving on, the process that we are all very familiar with is that we're putting our digits in columns according to place value. We are adding the ones or the units first. If the total is 10 or more, then we have to carry our digit across to the next column. And then carried digits are written in line with the next column. Now it doesn't matter if it's written above, below, or wherever, as long as it's in line with the next digits. And they're then added in with the next digits. So here we've got 7 add 6 gives us 13, but we want to write it like this. Writing the 1 first is really helpful. And if you model that, they will do that too, 13. Quite often we talk about, well, we'll put the 3 in here and then the 10 there, but that's not how we would normally write 13. We'd normally write 13 with the 1 first. So then we've got 5 plus 1 plus the 1 we've just carried over, which is giving us 7. 4 plus 9 gives us 13 again. So again, I would be modeling, writing it in this way. And then 2 plus 3 plus our other 1 we've just carried is giving us 6. Okay, so that's our answer. And the same is true of subtraction. Digits in their columns according to place value. Subtracting ones or the units first. If the top digit is smaller than the bottom, we're exchanging it. That's the language we use. We're exchanging and bringing a 10 or 100 or 1,000 into the column where there's a problem to solve our problem. We need to make sure that where we've borrowed, where we've brought one of them over, we need to reduce that column by 1 as well. So to take away 7, we can't do that, so we're going to have to exchange here. We're going to have to borrow one of these 10s. So we won't have 3 10s anymore because one of them's coming over here to help us, and we're being left with 2. So then 12 take away 7 gives us 5. We've got a problem again. We've now only got 2 10s, but we were supposed to be taking away 5. Not possible, so we're needing to borrow. We need to exchange one of these 9s, bring it across for us, which is leaving them 8. 12 take away 5 is 7. 8 take away 1 we can do, and 8 minus 4 leaves us with 4. So that is the process. Obviously, there's lots of places where pupils will go wrong with the exchanging and so on. But if we've modelled the reasons why and we talk through, well, we know we're needing to bring some of these across and exchange, and that's going to help us, then that will be familiar and they'll have less reason to go wrong. Moving on then to multiplication and division. We are practicing in this block multiplying and dividing numbers up to 4 digits by 10 and 100 using our place value. We're going to be multiplying 2-digit numbers by 1 digit using the distributed law, and dividing 2-digit numbers by 1 digit using that partitioning skill as well. So in terms of multiplying and dividing by 10 and 100, what they need to be familiar with is that in our place value charts, from right to left, each column is 10 times bigger. So 10 is 10 times bigger than a 1, and 100 is 10 times 10, and 1,000 is 10 times 100. So this is crucial knowledge, because if we want, therefore, to multiply something by 10, then it's going to move across these columns. So if we start with 5 1s and we're multiplying by 10, we'll end up with 50. Now they're familiar with the 10 times table, so they'll tell you that 5 times 10 is 50. So it's a good place to start, because you say, well, the 5's moved across, but you told me that 5 times 10 is 50. And they'll say, yes, that's right. So I said that, and you will say, well, that's because we need to put a placeholder, a 0, in the 1s column, because we don't have any 1s associated with this number. We can't just leave the 5 hanging there in the 10s column with nothing behind it. In the same way, from left to right, each column is 10 times smaller. So the related thing, the inverse here, is that if we start with a large number like 100, and you want to divide by 10, then that number is going to become 10 times smaller. So the digits that you have will move to the right. 100 divided by 10 is 10. All right, and we can model this, and we want them to become familiar with the pattern and the place value, and they'll say, and some of them will say, oh, well, you just add a 0, or you take a 0 away, and that's fine until you get into decimal numbers later on. So we need to also make sure that they're familiar with these concepts of the columns and the base 10 system that we have. You can do it with place value counters as well. So if we've got 24 times 10, if you really want to demonstrate to them, you could build 24 10 times, like that, and then identify to them that we've got lots of groups of 10 here, so we'll need to make exchanges. So each of those groups of 10 need exchanging, and they will need moving across into the next column. Some children find that a helpful visualization to do. So you've got 240 and you still need that conversation around the placeholder. The pattern they see is that they're adding a 0, but we need to make sure they've got this conceptual understanding, as I said, because let's say we're talking about multiplying 5.4 by 10. The answer is not 5.40. The answer is 54, because we are moving the digits across the columns. In the same way, you could talk about modelling 24 times 100. I don't think any of the pupils will want to make 100 groups of 24, but they might be familiar with 100 being 10 times 10. So another way of writing it is 24 times 10 times 10. So we know we've worked out 24 times 10 was 240. If we make that 10 times, we'll have the same process again, moving it across and seeing that we've got 2,400, and this time with 2 placeholders. So there are ways to model through what's going on with that place value skill. In terms of our second teaching point for multiplication, we've got 2-digit numbers by 1-digit number, but we're interested in the distributive law here. So we want them to think of that as 3 times 20 and 3 times 4, in which case that becomes really doable, becomes really approachable. And we're not moving on to column multiplication just yet. They could also think of it as an area model. 3 times 24. Most people would then split that into the 20 and the 4. They may prefer to split it into 10, 10 and 4. That would be fine too. They get the same result. 60 and 12 making 72. In the same way, for division, we want them to tackle division calculations with known facts. So here we've got 75 divided by 5. That's beyond our times tables knowledge, but we can use the multiples of 5 that we know to help us. So we know 50 divided by 5 is 10. We've also got 25 left. If we're splitting the 75 into 50 and 25, then we can tackle each of those separately. And then what's tricky with this calculation is them understanding that it's those answers they need to add together to find the solution. In the same way, you can model it as a reverse area model. So got 75. How did we get there? 5 times what made 75? Well, we're not sure, so we'll split it up into something easier to work with. 5 times 10 makes 50, and 5 times 5 makes 25. So then we've got our multiples up there. Okay. Fine, then our last core number topic is fractions, decimals and percentages. There are teaching points around fractions, decimals and percentages in every block of the progression. And that's so that we don't end up teaching fractions as just a block of work for 2 or 3 weeks at some point in the year. We want these to be revisited often. So I've got 2 teaching points here. One is to use division strategies to find a fraction of a quantity. It says a unitary fraction. That means that the numerator is 1. So we're just interested in 1/2, 1/4, 1/5 of, and we'll move on to multiples in the numerator later. And the other one is to make the fraction links to angles and compass points when we're doing our shape lessons. Okay, so as you can see, it's a very bite-sized moment of looking at fractions. We do need to remind them, though, about the notation of the fraction, what it's actually asking us. So they might be able to identify a third on that pizza, fine enough, That's because we can talk about how many parts of the whole we're talking about. So if we're talking about one piece of this pizza that's been split into 3, it's the top number is telling us how many pieces we're interested in, what we're talking about. Am I talking about one piece of it or 2 pieces of it? And the bottom number is telling us how many parts the whole has been split into. So the notation of 1/3 is telling us that the bottom number is telling us that we had a whole that we've split up into 3, and the top number is telling us we've got one piece of it, or we're talking about one piece of it. Using that visualization then, if we are looking at finding a fraction of a quantity like this, there's lots of concrete and pictorial ways that we can do that. So just like the pizza we just had, we could model a shape that's in thirds, and we could take 21 cubes and split them up into those thirds to very clearly see that each third is 7. 1/3 of 21 cubes is 7. We could then extrapolate that and talk about 2/3 of it being 14 and so on. So in terms of the rest of the teaching points, we've got 2 teaching points around shape and space, and then we've got information handling in this block as well. Shape and space come in block 1 of every year group and block 4. And the data handling topic comes 4 times in the year group. So if you're working across planners because you've got composite or because of the nature of the pupils in your class, then you will find that the topics align by block. So 2D shapes is a focus of this block teaching for shape and space. Similarly, 2D shapes feature in block 1 of P3, block 1 of P7, block 1 of P4. Okay, so you get those mini progressions across the planners. We're also going to look at compass points in this block too. And we mentioned already from fractions, but we haven't talked about it, to make our fraction links in terms of angles and compass points when we're looking at directions. So in terms of 2D shapes, we've extended our familiarity with 2D shapes up to 10 sides by the end of primary 4, by the end of first level. We've also introduced the idea of the families of regular shapes that have all sides equal and all angles equal, and irregular shapes as well. What we want to move on to as we move into second level with shape is having a more mathematical vocabulary to describe shapes. So how many right angles can we see, equal lengths, the sides, the corners, have we got anything that's parallel? Can we talk about regular and irregular? What about symmetry? So we should have a wider range of discussion around shapes and how we describe them, how we sort them, what criteria we can use for them. We can encourage lots of exploration through problem-solving tasks and use of shape in other areas of the curriculum through STEM and expressive arts and so on as well. And then in terms of this second teaching point, in primary 4, we've already met the compass points, but just the four single letter labelled points, north, south, east and west. We're adding into that in primary 5 the interim points of northeast, northwest, southeast and southwest. They are new for this stage. In primary 3 and 4, we've talked about turns in terms of a quarter turn, a half turn, a full turn. But now, and this is the link from fractions, now those fractions we are relating to the complete circle being 360 degrees, and this is new information. So they know that a right angle is 90 degrees. We need to then build up that knowledge so that, as well as being able to say a quarter turn is the same as 90 degrees, and say I turn 90 degrees clockwise and 90 degrees anti-clockwise, they need to become familiar with those multiples of right angles. So 2 right angles makes a half turn, and 2 times 90 is 180. So a 180 degree turn is the same as a half turn. And we can build it up with 270 and 360 as well. And crucially, because we've got our 8 compass points, we're going to need 45 degrees as well. So understanding that the bisection, the halving of a right angle, gives us 45 degrees. These are what I would call landmark numbers in terms of angles. So just the same way as we become really familiar with on a clock, 15 minutes, 30 minutes, 45 minutes, and 60 minutes. And we become very confident with landmark percentages like 25%, 50%, 75%. This sequence of numbers, 45 degrees, 90 degrees, 180, 270, 360, is a group of numbers that they need to become familiar with. And it's worth having a display of those core numbers for them to see and be aware of in your classrooms. So once we've got that knowledge exposed to them, we can talk about versions of the directional language problem that include those things. So whereas in P4 we had Aidan is facing south, he turns a quarter turn clockwise, which way is he facing now? We've upped that complexity. Now we've got Aidan facing northeast. He's turning 45 degrees clockwise. Which way is he facing now? Okay, so we're layering on to known information, some more mathematical concepts in this stage. Zainab's facing west. What turn should she make to face east? So a little bit more complex in the questioning there. You may have available to you in school these amazing robot programmable devices called Spheros. If you do, they are amazing for this area of the curriculum. You're able to code them so that they can follow a path, and the degrees and the turns are really helpful for that. A little bit more old school, you might remember using Logo yourself at school. Logo is a basic coding interface. There's a link to a version of it that's available for free online there. You program the icon, which they call the turtle, to draw a shape. And so there's really good links and good lesson potential to link this teaching point with the awareness of 2D shapes that we had in the previous slide, in order to make the turtle draw, let's say, a regular hexagon. They will need to have awareness of the angles and awareness of the number of sides and so on. So those are really helpful and interesting digital supports that you can use if you have access to them. And so finally, our last teaching point for this block, under information, data and uncertainty. By primary 5, we've already been exposed to bar charts, pictograms and other tables with tallies and so on. But a new skill for this year group is to look at line graphs. Line graphs generally are used to display continuous data, continuous in terms of a data set that could be any value, so it's usually measure of time, compared to discrete data, which we would record through categories. So a bar chart lends itself to discrete data because perhaps we're having people choose a particular category, or we're saying how many there are. But if we wanted to record a chart of pupils' height, then unless we band particular heights, it's difficult to display that on a bar chart. So line graphs are a departure, and that's for continuous data. So lots of examples on the slide here, particular questioning that we can engage with for them. So if we're looking at the top left display there, we're looking at the visitors to different rooms in what I assume must be a castle or similar. Which room was the most visited? Very straightforward questioning. How many more books were borrowed on Friday than Tuesday? A little bit more complicated in that they've got to look at 2 data points and find the difference. How many books were borrowed in total for the library display at the bottom left? Got to do some calculation to work that out. And then the line graph sort of questioning, because this is a new type of graph, we want to make sure that they are confident with just reading the data points. So what was the temperature at 3 p.m? And then as we move on from that, what's the difference in the temperature from the highest to the lowest, and so on. So we're extending the range of data displays that they're familiar with and able to work with. It's worth pointing out that within the literacy aims of the curriculum, there's this lovely table of examples of text types, and data and graphs are listed there as a type of literacy text. So when we're engaging with data handling, there is lots of literacy going on as well there. You might also want to consider using what we call goal-free problems for primary 5s. This is something Education Scotland's numeracy and maths team have promoted a little bit over the last few years. Effectively, the discipline is that you present pupils with a graph or charts and just ask them what they can tell you about it. So the sequence is goal-free in terms of there's no direct questioning. And I think that a good analogy with that is when we talk with children who are about to do a reading comprehension that has questions attached to a text, we quite often will discuss with them how important it is to read the full text before then looking at the questions. What we don't want them to do is to read the questions and then just search through the text for the answers. And the same can be true of data as well. If children haven't engaged with the full picture of the table or the graph that's in front of them, if they're just searching for the answer to a question, then their understanding is going to be less good. So it's quite a good discipline to get kids to look at the data first. What can you tell me? What's it called? How do you know? What else could you find out? And then they will probably find when a question is given that they already have got halfway to the answer there. So that's us got through the content of Primary 5 Block 1. If you have any feedback or questions to ask us, please use the QR code there. That will be logged for you. And if you leave, you want us to get back to you, then leave your name or your email and we'll come back to you with some feedback. As I mentioned, there is a plan to have end of block assessments available. These are in development and we'll be communicating out to you at the beginning of the new school year what's happening with those and when you'll have them available to you. These webinars have been run for each year group for block 1, and the intention is to run them again for blocks 2 to 6. So look out for those listed on CPD Manager. Please do come along. They will be recorded in the same way. So if you can't come on the dates that they are happening, then you'll find recordings on the Microsoft team, which we mentioned at the beginning. So just a reminder of that team joining code there, and my email address is there if you need to get in touch. The last couple of slides on this presentation, and it's available to you in PDF as well, are any links that I've referred to in earlier slides. And at the very end, this is a set of QR codes that are useful to have on tables for the kids to access the MathSpot manipulatives from their iPads. Just means they don't have to be searching up MathSpot and finding the manipulatives menu and so on. They can see exactly which thing they're looking for and just scan it and go straight there. Thanks for listening. Hope it's been useful.